Hi, my name is Christof Ebert. I'm responsible in Vector for consulting activities worldwide. And a big portion of what we are doing is related to cybersecurity. And I will show in this presentation about security testing. The relevance of security testing is that you have to ensure that you cover different needs along the life cycle, including the maintenance of the product. And we will show you some hands-on guidance, especially for the Vector gray box pen test, which is very helpful in order to have an efficient and effective security testing. So let's look into gray box penetration test for full lifecycle cybersecurity. That's a quite bulky title, which has three major elements. First, methodology, gray box. It's not black, it's not white. We try to combine both. Pen test, because often it's neglected and insufficiently done. And full life cycle, because we need to focus on security along the life cycle. With classic IT systems, which you certainly know, like your smartphone or your laptop, you typically have the following situation. You make an update. 1 day later, there is the next update because the first update had some security flaws. Now, this might be traditionally acceptable for IT systems, but for automotive systems, we have to pay attention because it's safety critical. And therefore, not everything which we know from IT, we should copy into our automotive cybersecurity. In this presentation, I will have a very short introduction towards what we are doing in Vector. Then we look into methods for security testing. We look into a concrete hands-on case study, pen test in 10 steps. And we have a summary and discussion at the very end so that you can also ask your questions. One word on Vector as a group. We have about 3,300 employees worldwide. We are active in many countries in the world, mostly where there's automotive customers. We work quite successfully along different domains. PLM, ALM, that is for our provision tool. Embedded software, where we are with AUTOSAR market leader and have a lot of very advanced security functionality in the AUTOSAR-based software. Testing, which, for instance, brings a lot of good and strong test functionalities along the life cycle, like our CAST tool, but also the tools which are Canoe with fuzzing environments, etc. Diagnostics, which is a topic where we already deploy a lot of security for innovative diagnostic mechanisms. Calibration, and also the consulting activities, which is my responsibility. Let's look into security test methods. And the major message which I want to pass in this presentation is that classic security implementation, verification, validation, as we know it from IT, is not entirely applicable towards automotive. On the one side, we need a systems perspective. For instance, always be focused on cost efficiency, because we will have in the future more and more frequent delivery cycles, which all have to be secured. So cost is a key topic, but also there's a need for transparent and efficient regression strategy, because in the regulations like CSMS and SAMS, we need to be able to show that we have covered the underlying security management strategy. We need to have traceability from the impact analysis to the documentation, and we should have, from a perspective of transparency, efficiency, cost effectiveness, but also usability, tool chain, which is as much as possible automotive. And that's one observation which we have with many of our consulting projects, that often the tools have organically grown, but they do not really fit together. There's some ALM, some PLM, some requirements engineering, some test tools, but nothing which closes it together. And a key topic with efficiency and cost effectiveness is to have a strategy. How do you document your security? Because that's exactly the expectation of you in ECE R155, which is about cybersecurity management system. And when it comes to the updating, that's the R156, the software update management system. Both need consistent documentation and flow of the traceability from the impact analysis to the delivery. Now, also inside the testing, we need new methods. And this is really bottom up. That's why I said in the introduction, it's not just to do one type of testing. We need to start out with defensive coding. We need to apply coding rules, simple coding rules, MISRA, all these topics which we hopefully are already used from functional safety. We have to also apply here. We need to have a good strategy with cryptography, which is key management, but it should also balance performance and the life cycle risks. And I mentioned two aspects which we often see in our consulting perspective, which is if the chunks are too small, the performance need is quite high. So we have to balance, we have to reduce the amount of individual cryptographic mechanisms in order to facilitate, let's say, good performance. On the other side, we should not now build too small keys, because later on we will see over the lifetime of a car, which is, let's say, 7 years, which sometimes could be 10 years, that during this lifetime we will see strong advances with respect, for instance, in quantum computing. We have been working recently on this field with one of the major suppliers, and we see now how the qubits are increasing. And that means in turn that we already see some proof of concept how to build a quantum computer for cracking of encryption keys. In other words, within the next 10 years, we will see a lot of such changes. And I don't think we should build now cars which after 3 or 5 years cannot anymore be used because of insufficient security strategy. That would also be a waste from an ecologic perspective. On the next topic, which is AI and machine learning, we have more and more autonomy in the near future. And that means there are novel security attacks, such as faking of the signs, such as sensor blinding and all these mechanisms which we had in the past not really considered. Then we need to have automatic regression test schemes which ensure consistency. We need to have a risk-based penetration test. That's one of the focus of this presentation. And not the least, also ensure that we have sufficient governance towards social engineering. That's one of my favorite. Surely social engineering has changed a lot in the past year. With the pandemic, we are now more vulnerable because in the home office, there are not always all rules as closely obeyed than if you work on site with your employee. But that's exactly the risk which attackers now make a lot of attack schemes, that they attack you in your home office and claim that they are this and that remote colleague which needs some information. And the attacks with this social engineering have increased a lot in the past year. So be aware, because here is not much mechanisms to use. The infiltration of your IT equipment at home is certainly more challenging because of Trojans, because of spam and other, let's say, mail and other attacks with phishing, with scripts, etc. And this is something which, of course, can be mitigated with a lot of firewall, VPN, etc. But the first attack is always via the person in front of the PC, so be careful here. To summarize, the classic test is not anymore sufficient. We need to test for the known and for the unknown. And that means along the life cycle with verification, validation, and the life cycle management, we need different technique, from the static analysis to dynamic analysis with unit test, fast testing such as brute force, and then the pen test, which a connection of misuse, abuse, and confuse schemes, and the post SOP and the continuous maintenance, such as PCERT collaboration, like which is the Product Security Incident Response Team, and of course, as I mentioned already, OTA and SAMS, to ensure that we deploy along our CSMS guidelines. Security test needs traceability, and that is a traceability from the right to the left, that a test case is related to the requirements, and the test case should, in the best possible case, be developed with the requirement, and then vertically, of course, also the different abstraction levels between the asset and the TARA to the functional security requirements and the technical security requirement. And that means we are in a 10-step risk-oriented security process, which we have summarized here, and we will later on show how this works in practice. From the initial reconnaissance, that is understanding the environment, into the asset analysis and the TARA, towards the specific security requirements and the related test activities in order to achieve minimum viable test strategy based on using KPI. This is the topic which we follow here. And there's, of course, a lot of methodology, which I can only sketch in this presentation, but you will get a feeling. And if you need more, of course, you know where to knock at the door, which is vector.com. Now, the starting point with any risk-oriented testing is that we understand the TARA, that we understand the threats, and that is we typically use TARA, an intelligent threat analysis tool such as our Compass, where we document, we can reuse assets and also the threats, and then we make the prioritization based on the 21434, as we see in the right corner. Traceability then typically follows the triple peak model. Here is just an excerpt. If you want to get more, there's also literature like our recent article in IEEE Software where we combine all that. So we go from the upper left, which is we have these negative requirements. Then we have on the one side test-driven requirements engineering, TDRE. That means test case based on the requirement in the best possible case. For these negative requirements, like a misuse case or an abuse case, we directly create the test cases together with the requirement. This is the forward TDRE. And backwards, when we execute a test case, we check, is there value based on the KPI? That's number one. And number two, in case there is no negative result, maybe the test case is redundant, maybe we have to implement. For completeness, on the bottom, we have also the traditional TDD, test-driven development. So both help each other and therefore support each other. Now, these different test strategies should be combined, intelligently combined, in order to improve efficiency, because each abstraction layer needs their own specific testing. And I will show here with the example of fuzzing and penetration that we, of course, combine it. So when I speak here about pen test, gray box pen test, obviously we also use fuzzing technology here, because fuzzing, that's based on intelligent brute force, helps with understanding attack schemes where you need a lot of permutations in order to find something, while the classic risk-oriented pen test looks into a specific misuse case. So the combination is helpful, and that's also what we see if we compare different security test methods, that there's not the one single best where we can say this has a strong effect both in effectiveness and efficiency, but we rather see each of those is important. Certainly from perspective of whole system, gray box pen test, which is what I will also explain more in the next part when we look into practical application. Gray box pen test has a big value because it combines the best of in terms of system pen testing, in terms of a system level complete security test. So let's have a look into pen test, and we will just put that into the 10 steps, which we showed already in the previous chart. And the first step is always, as so often, start with the end in mind. So you certainly know the famous book of Stephen Covey, which is the 7 habits of highly effective people. And one of these habits is start with the end in mind. And that means understand, try to imagine what would be the goal of a hacker, what would be the goal of somebody who attacks your system, your vehicle, or a specific component of the vehicle, and then distill the negative requirements from it. And that means we need initially some reconnaissance in terms of what is the system, independent of what is the scope. I mean, scoping is anyway a topic during requirements engineering, but once we have an understanding of the scope and the context, then we start already developing the negative requirements. And with the negative requirements, this is typically misuse, abuse, confuse cases, for instance, we start to get an understanding what would be attack schemes. Now, as engineers, we tend to think positive. That is, we always see the sunny day scenario. So it's always good to have some negative people in your team. I mean that literally, because obviously we need to have a negative perspective. That's, by the way, why companies come to Vector to do security testing, because we are not in a mode of a developer or tester which mostly think, I want to somehow show that I did a good job. Our role in pen test is not to blame somebody, but to show that the job can still be improved. So it's good to have external, we call it white hat pen testing, and that's exactly what Vector is doing, what we are doing globally, that we perform pen test. By the way, we do that much more efficient than the classic pen test companies, because unlike the others, Vector really knows about automotive EE, networking, attack schemes, tools. So we bring a combined knowledge of the whole Vector group into this pen test, and that's of course a big difference compared to asking an IT pen test company doing your automotive pen test, which typically does not really give you a 360-degree coverage of all negative cases. Second step, make a structural analysis of the underlying architecture. Why do we do that? Because knowing the components, knowing the networking helps to understand what are the attack schemes. Then we look into the assets. That is primarily what we also do with the TARA and how to understand what are the assets in order then to create a specification and therefore also typical attack schemes, which we use then to specify our pen test. And on that basis, we then document, we call it a mini TARA, a small TARA, the threats, the impact, and therefore give also a documentation by using Compass into what is our pen test strategy and what is the coverage, what is our regression strategy, etc. With the pen test cases that is related to this test and requirements engineering, we categorize those, such as for which part of the system they would be used, with which relevance, so that we also can document already the regression test strategy, the focus if a component is changing, which of these test cases do we need to repeat. Then we perform the penetration test, and that is we connect the different tools from the outside. That would be a more black box approach. Sometimes customer ask us also on specific attacks on a component, but in all cases it's a normal pen test, but based on steps 1 to 6, we know exactly where to start, and we don't waste time and effort by test cases which are of no impact and don't really give us any insight. A good example is the flashing of a software, because often these are topics where external pen testing fails because there's insufficient understanding about the whole mechanisms of flashing. And this is, of course, one of the core disciplines of Vector, where we bring a lot of experience and therefore the yield is higher. That is the better effectiveness. But of course, we also have to measure. This is why we put in step 8, dedicated KPI for effectiveness and efficiency. So we look into what vulnerabilities and what categories, so that we can balance the effectiveness, that is how good we are in terms of yield, but also the efficiency, that is how good our test cases are in filtering, in pointing into specific vulnerabilities. Now, along this way, we also realize that we have to update our functional security requirements. And this is step 9, because of this TDRE approach, it means when we write a test case, we also improve the requirement. This is what is the logic behind the triple peak model, that we move from the abstract, the peaks downwards, to the more concrete. And that means also here and there improving the design, improving the requirements, the specification. And that's normal in any security test, that a good security tester would also point into weakness in the design, in the architecture, or maybe in the specification in order to improve. And that means we have to update also because during the life cycle, there's new functionality, change functionality. So this test scheme, which is iteratively applied, would also yield a good insight into what is the coverage based on a good effectiveness and efficiency. And that brings us to the last step of this 10, which is it's a life cycle activity. That's why I put the title life cycle focus, because we cannot just say, well, it's now SOP, things are done. Life really starts after SOP. We have software updates, we have changes, we have new functionalities. That means also that we have to protect all these updates. And I said in my intro, we should avoid that we do the same, let's say, behavior as we see with some IT companies, which deploy a change and half a day later you get the next point release because the first one had some security flaws. We better do our job before we deploy and bring that into a continuous mechanism covering the life cycle from security by design to the supply chain, to the provisioning, and to the monitoring with PSIRT, and therefore have a good and solid regression test scheme. Now, with these 10 steps, which we have seen with a live example, I think you have now got an idea about what is the benefit of a systematic, risk-oriented, life cycle-oriented test strategy. We focus primarily on gray box pen test, but nonetheless, of course, the portfolio of Vector has much more to tell. We have more presentations along, and you will certainly also see that here is some which we can learn, and that's also part of our portfolio based on the tools which we provide, the test tools based on our underlying base software, which has really set the path in terms of security library, starting with AUTOSAR 4.3 and now moving into AUTOSAR Adaptive, which facilitates over-the-air updates, but also ensures that we have the right security scheme in adaptive software and the related services which we are providing for security analysis, for security concept, for efficient implementation of ISO 21434, UNICE R155 CSMS, UNICE R156 SAMS, and of course also the bridge into automatic and autonomous driving with SOTIF and the related cybersecurity using the R157, for instance, but also then the support directly hands-on, for instance, by our virtual security managers who help you on call basis in case of questions with respect to your security implementation. And this package is something which in the portfolio of Vector is novel and very helpful. And with this, I've finished, and we look forward to your questions and hopefully also the right answers to advance you on security.